Hutton was a man that understood the mysteries of the process that took place that led to the shaping of the earth. Hutton's work was very hard to understand, resulting in complications when people viewed his theories. Hutton, a famous geologist, dies and John Playfair takes his work public and expands his writings. He started out studying medicine but then continued on to work as a scientific farmer on his family's land. As he progressed in his business, he began producing steel ammoniac from coal soot and continued his research in scientific fields in Edinburgh. Little by little, Hutton gains fame and becomes a leading member of the prestigious society called the Oyster Club. In this club, he got a chance to interact with people such as Adam Smith the economist, David Hume the philosopher, Joseph Black the chemist, and Benjamin Franklin. Hutton was particularly interested in geology, but he also excelled in other fields such as coal mining, fossil collecting, metaphysics, rain, air composition, and the laws of motion. A question that puzzled people at the time was why ancient clamshells and other marine fossils were so often found on mountain tops. How on earth did they get there? People who thought they found a solution were split into two groups. The Neptunists, which believed that everything was explained through the rising or falling of sea levels, and the opposing group, the Plutonists. They believed that volcanoes and earthquakes are what changed the Earth's surface. When Hutton stumbled upon such questions and ideas, he began to come up with exceptional predictions and theories. By observing his farmland, Hutton saw the soil cycle in place and he was able to recognize it. He saw the erosion of rocks and how they flowed and transformed into soil and got washed away by rivers elsewhere. From this, Hutton would thought that if this is the only cycle, then the Earth's surface should have been flat, and without any hills or mountains. So he recognized that there must be other cycles taking place that result in the thrusting up of mountain chains and the marine fossils on mountain tops. He decided that the marine fossils started on the ground and were driven up by mountains. He also decided that the heat from the Earth's core was a result for the formation of the continents and new rock. Hutton gathered all his insights and began writing a long paper in 1785 that was recognized and read at meetings of the Royal Society of Edinburgh. His long paper was complex and sophisticated that no one had interest in it at all until Hutton spent his next 10 years making his major creative work that got published into 2 volumes in 1795. Playfair wrote the Newtonian Principles after Hutton's death, illustrations of the Newtonian theory of the Earth. The Geological Society was formed in Covent Garden in 1807. The idea was to meet once a month to swap geological notions over a glass or two of Madeira and a dinner. Throughout the modern thinking world, but especially in Britain, men of learning ventured into the countryside to do a little stone breaking. James Parkinson, an early socialist, was interested in geology. He became a founding member of the Geological Society. He was known for his study of Parkinson's disease. Charles Lyell was another founding member of the society. He was a student of William Buckland. Buckland became a leading authority of fossilized species. He went on a tour with Lyell in Scotland in 1824. Lyell became geology in 1833. Geological controversy arose between Hutton's day and Lyell. An argument between catastrophism and uniformitarianism. Catastrophists believe that the Earth was shaped by abrupt cataclysmic events, example floods. Uniformitarians believe that changes on Earth were gradual and nearly all Earth processes happen slowly over immense spans of time. Lyell was a uniformitarianist. He rejected the notion that animals and plants suffered sudden annihilation and believed that all the principal animal groups, mammals, reptiles, fish, and so on, had coexisted since the dawn of time. Darwin was a fan of Lyell. He read his book on a voyage. Geologists tried to categorize rocks by their periods in which they were laid down, but there were often bitter disagreements about where to put the dividing lines. Geological history was divided into 4 strands of time: primary, secondary, tertiary, quaternary. Today only tertiary remains as a common designation everywhere, even though it no longer represents a third period of anything. Lyell and his principles came up with units of time to cover the period since the age of the dinosaurs. Nowadays, and speaking very generally, geological time is divided first into four great chunks known as eras: Precambrian, Paleozoic, Mesozoic, and Cenozoic. Rocks are divided into quite separate units known as systems, series, and stages. A distinction also made between late and early, and upper and lower. Before the 19th century, geologists could place the various rocks and fossils in order by age. They had no idea how long any of those ages were. People persisted into finding how old is the planet we live in. There were many theories, measurements, and guesses from different geologists. Archibishop James concluded a date when the planet was born, but his claim was not supported. Edmund Halley came up with a better assertion. He said that we could measure how ancient the world is by measuring the salt in the sea, and the salt added each year and divided by the number of years. There were several other attempts that came after until Darwin came up with his calculations. He announced that the geological process created the wheel had taken by his calculations 300 million years to complete. This mystery drew the attention of great Lord Kelvin. Kelvin was known for his genius mind and the many achievements in electromagnetism and the wave theory. Nevertheless, the one question he could not answer was how ancient the world is.